Hello guys, my name is Siddharth Varde and this is another devlog of Data Structure Fundamentals 1. As I said in last devlog, what we learned was the basics of string, right? So like what is string? Like how it works underneath, what are the different functionalities of a string? Uh, like what can we do with a string class provided by the C++? So basically a string is just an array of characters, right? So it is a class that like the string is a class that will store an array of character. Uh, so like that would make it a string, and then like there are different functionalities provided by it. For example, let's say I want to find a particular uh, letter if it exists in a string or not. So those kind of functionalities are provided in the class, but like in this time what we like learned about is how we can perform it on our own and how we can perform it easily kind of thing, right? So the and yeah, even in then the like how to do it effectively kind of thing, and converting a string into an ASCII characters kind of thing, like that approach is very good, like quite good, and very helpful a lot of times. So not maybe not in every time, but still a lot of times. So that's a very good thing that we did, and like that we learned. And for example, let me show you an example uh, here. Okay, so there is a given input of a string, and uh, yes, like which character appear how many times? We have to denote which character appear how many times. Okay, so what we did, like, just first of all just get an string input. Okay, then I created an array of 256 elements. 256 because there are like in ASCII values there are 256 characters, that's why. And then there is an another notation after an ASCII that has an 65,000 characters, so that's an another one, but we are converting it to the ASCII. So like that's an that another thing that I said about another version. That's an like kind of ASCII next level of ASCII. Like it was created after an ASCII to store like kind of different languages, because ASCII is not like 256 characters, right? And there are many languages. So like uh, it cannot contain every letter of every language. So that's why it was updated to 65,000 characters. And that's in another version, but still, first 256 characters are from the ASCII. So both in 256 characters would be the same in both the versions. So we are converting it into the ASCII. Okay. So I created in 256 characters. So 256 characters means like 0 to 255. Okay. So that would go in there. So what we like first of all I made them all zero, okay, and then we take an input one by one. A string is in character of array, right? So we can take an one by one element, each and every element one by one, and then I said whatever the position, like for example, let's say small letter a, so it has an 65 value. So I would increase the 65th element of the array, like that element would be increased to 1, and if I get 8 second time, then it would be 2. So in and after that, what I do is traverse again from 0 to 255, and if I find that a particular number, for example, as I said, 65, right? It was found twice, I guess. So like its value would be 2, right? Address I 65, 65th element of the array, its value would be 2. So if it is greater than then I would say, okay, convert 65 into an character, okay, and then print whatever the values were that was stored at that. So if I run this and enter in, okay, so A, B, C, D, E, R, T, and Y. All of them were one except C. C were three. There were three C's. So like it's an O of an N. Like the time complexity would be O of n, right? Plus 250, like twice 256. So that's a kind of a constant. So 512. So let's say the strings input is like 1000. Then I would say the total iterations that I would have to go through is 1000. Yes, 1512, right? So, like the bigger the number gets, it's because of it's an O of n time complexity, it becomes better. For example, let's say if I have chosen another approach where the time complexity would be n square or n log n, then it would increase, right? So, for example, let's say 1000. So, 1000 would be if n log n, if time complexity was n log n, then the 1000 would be multiplied by 10, right? So that would becomes that becomes 10,000. But here, in 1000 number, we are saying like the only iterations are that we are doing is 1500, 1512. So it's like even though we are creating an array of 256, it's quite effective on time complexity. So it's a very good approach. And again, the array of 256, right? So one integer would cost an 4 bytes, right? So like 256 integer would cost in 1024 bytes. So it's just 1 kilobyte. So like 1 KB of RAM, like on the cost of 1 KB of RAM, we are getting output very like the time complexity is reduced very much. So this is the kind of power of an like technique, like using an ASCII characters is quite effective and very good. So that was an update. Thank you.